Hello students, this is a review of the exponential and logarithmic equations practice. This is lesson 3 in the 0th unit, the algebra review unit. We already did some of these in class, so I'm going to show you some of the answers, and then I'm going to get into some of the selected examples a little bit deeper. Hopefully that will be helpful to you as you study for your quiz on exponential and logarithmic equations. Let me show you a couple of these answers. Here's the answer to the first example. As you can see, we took the log base 2 of both sides because we had an exponent on base 2 here. So we chose the same base as was given to us, log base 2, because we had a base 2. Log base 2 and 2 to the power of whatever, that's an opposite operation, which means it eliminates, it cancels out. So log base 2 of 2 to the x just becomes x. Another way you could think about it is this. What exponent on base 2 gives you 2 to the x? Well, the exponent is x. So there's your answer. On this side, however, we have to finish it off by saying that's the log 2 of 7. So we're going to finish it off like that. And there's your answer. Log base 2 of 7 can be evaluated on your calculator, but I'm not asking you to do that on your calculator. I'm just asking you to leave this unevaluated. You can leave it just like that. All right, let's take a look at some of the other responses. Question number 2 was also fairly straightforward. We used log base 4 because it was given to us that we had the base of 4. We used log base 4 on both sides, and we eliminated log base 4 and 4. X plus 1 was the only thing left on the left-hand side, whereas on the right-hand side, we could evaluate this. This gives us a decimal. We're just going to leave it like this because it's easier to algebraically manipulate. If I asked you to find it to the nearest 4 decimal places, I'm confident that you'll be able to use your calculator to figure that part out. We solved for x. We got x by itself by subtracting 1 on both sides, and we got log base 4 of 3 minus 1. Let's go on to some of the other problems. All right, and hopefully you can see that this equation is solved very similarly to the second equation. We're taking log base 3 of both sides because the base here was 3. We solved for x, in other words, got x by itself, so we got this exponent as a regular expression, and then we added 3 to both sides to get log base 3 of 5 plus 3. Let's take a look at the next one. This problem was the first that involved using the natural log. We used the natural log because it has e on this left-hand side. That was our base. So natural log, in other words, is saying the logarithm with the base of e. It's called the natural log because it's one of the most common logs. But it's not the most common log because it's not common log. Anyway, e and ln eliminate, so we're left with 2x. And 5 over 2 on the right-hand side still becomes, is taking the natural log of. We haven't done anything to that because it gives a decimal. There are a lot of other pretty ways you could write this. You could write this as ln 5 over 2 divided by 2. You could say 1/2 times natural log of 5 over 2. There's a lot of other ways you could write this, but this is simply one of the correct answers. Let's take a look at the next one. Number 5 was very similar to number 4 in that it still had that base of e. We used ln natural log because it was the base of e. We were able to eliminate natural log in base e and get 3 minus 2x. Notice that in most of these problems, we're applying a log or a natural log or something like that to one of the sides of the equations, but we're not evaluating it. It's okay to leave it. This is going to be a decimal value, so we're just going to leave it in its exact form rather than having to round to an approximate form. Again, this could be written as 3 minus natural log of 4 divided by 2. My eagle-eyed students would likely tell me that I lost a parentheses in there. And as I said, it could be written in other ways. Let's take a look at exercise number 6. Question number 6 was the first that gave us a little bit of a hard time in class. The problem looks like a quadratic, and you see that we rewrote e to the 2x as e to the x squared. Looks like a quadratic, but it may be hard to see which part is the variable, like the x part. So we're going to use substitution to make the problem easier to answer. The substitution that I used is calling e to the x just the variable n. So if we rewrite this equation using e to the x as n, or in other words, taking out e to the x and putting in n, it makes it a little bit more straightforward, easier to factor, and then we're going to put the e to the x back in. We're sort of making it a little simpler to answer first, and then answering the complete question. So now you see I replaced all of the e to the x's with n's. Now it's a little bit more straightforward to see what we need to do. We're just going to use the add and multiply method. We're finding two numbers that multiply together to give us -6, and that add together to give us -1. And now that we've factored this expression into n minus 3 and n plus 2, we're going to take these n's and put back in e to the x. And it'll make it a little bit easier for us. It has made it a little bit easier for us to solve now that we've factored it. And now we're going to use the zero product property, which says any two factors that are multiplied together to equal 0, that means each of them can be 0. So we're going to split these up, put the e to the x back in, and then solve it. All right, we've finished this problem off. The first thing we did was split into two different equations. Now that we know that n minus 3 is going to be equal to 0, we're going to put our e to the x back in. So you can see that I did that substitution, and I solved just like I normally would. I would add 3 on both sides here, subtract 2 on both sides from here. I take the natural log of both sides because my base is e. So I got x equals ln of 3, or natural log of 3. I also got x equals the natural log of negative 2. You gotta cross that one off. And why? Because it is, of course, an extraneous solution. I'm going to write this in red. Very important here. Extraneous. And we call it an extraneous solution because you can't take the natural log or any logarithm of a negative number. It just doesn't work. You try it in the calculator, it gives you undefined or error. All right, let's take a look at the next problem. So we'll step you through number 7, line by line. You can see that I rearrange it so it looks like a quadratic. Then I did my substitution. I said that n was equal to e to the x, and I replaced all of the e to the x's with n. Then I factored, just like you factor a normal quadratic. I saw it was a zero product property problem, so I did the split and solve method. After I split and solved, I got the n by itself, and you should now know that e to the x can be put back in for n. And we continue solving by getting x by itself. We take the natural log of both sides of both equations, and we were able to simplify the left-hand side up to here. But the right-hand side, notice that the natural log of 1 is just 0. So that's the appropriate answer there. So you get two answers, x equals 0 and x equals natural log of negative 2. You should remember that in the previous problem, we crossed off one of the answers. It was extraneous because we were not able to take the natural log of a negative number. However, in this problem, it's perfectly legitimate for us to take the natural log of 1 and the natural log of 2. It's okay as long as the number is not 0 or below. Let's take a look at the next problem. You may remember this from class. I did not expect you to complete this problem because it required the use of the quadratic formula. We got it to a quadratic which was x squared minus x minus 1 equals 0, or n squared minus n minus 1 equals 0. Regardless of that, it can't be factored with the A&M method, so we would use the quadratic formula if we were to try to complete this. I will not hold you responsible for this type of question in class. Onward and upward, let's take a look at number 9. Now for this problem, it does have e to the x in it, but it does not require a substitution. The previous ones required substitution because they did not have common terms in every single term. You may remember that the number 7 had e to the 2x minus e to the 3e to the x plus 2. They both had a common term of e to the x here, but 2 didn't. When I look at number 9, though, every single term on that left-hand side has a common term of e to the x, so I'm going to factor that term out. Once I do that, I have a 0 here, so I'm going to use zero products property, split it up, and solve it like that. All right, at this point, you can see that we split off into e to the x equals 0, which led to x equals ln of 0. Recall, however, that this is what's called an extraneous solution. We call it an extraneous solution because we can't do it. There's no possible way that we can find the natural log or any other log of a 0. We call this extraneous. Next, we take a look at the other side. 3x plus x squared is equal to 0. We can also factor this and use the zero products property. So we're going to split this yet again. And it seems like this could have gotten a little crazy, but thankfully it did not. We were able to factor x times 3 plus x into x equals 0. There's an answer for you, and there's a weird circle for you. X equals 0 is one of your answers, and then on the other side we would have gotten x equals negative 3. That's another answer. Two answers for this question, not the third one because we call this one extraneous, and I'll write that in just in case you wanted to know how to spell extraneous. All right, on to the next problem. Now this problem is the first in the problem set that required the use of what's called exponentiating. Yes, that is a verb. I looked it up. When you talk about exponentiating, you take a natural log or any other log that's pre-existing in an equation, and you eliminate it with its opposite operation. You should remember that the opposite operation of natural log is e to the power of, because natural log has a base of e. In other words, this is saying e to the power of whatever to the power of e gives you x. Sort of a complicated way of thinking about it, but think about it like this. They eliminate. Boom, done. On the other side, you got e to the 8th. That's a decimal. We're not going to evaluate that. I am going to make a few notes here. All right, so you can see that the opposite operation of ln of x, taking the natural log of any value, is taking e to the power of that value. And also at the end, we can say no need to evaluate because we can leave it as an exact answer. Let's go on to the next problem that will also require exponentiation. All right, as a general rule, whenever you're looking at a logarithm in an equation, you identify the base first, and that's the value you need to exponentiate to. And yes, I looked it up on Wikipedia. Exponentiation is a word. Anyway, you know that the base is 2, so we're going to put everything to the power of 2, or in other words, put 2 to the power of everything. We can evaluate 2 to the 5th very easily by saying 32. So 32 minus 2 is equal to 30. Let's take a look at the next problem. All right, we did something very similar to number 12. We had just the log on the outside, so we were able to take this equation, exponentiate both sides. We found that 25 minus x was the exponent, but it just became the argument on the left-hand side, and 7 to the 3rd power is 343. We solved for x and got negative 318, not 19. Anyway, moving on to the next problem. Now you see in this problem that it's not log by itself on this left-hand side. It's 4 plus 3 log of 2x equals 16. We're going to do some stuff to get rid of this 4 and this 3, and then we'll be able to exponentiate using base 10 because this is a common log. So let me show you this one step by step. The first step is to write the original equation, and then we're going to move the 4 to the other side by subtracting by 4 on both sides. Next, we're dividing both sides by 3, and as you may remember, you can take the 3 and make it an exponent, but that would not be advantageous in this problem. Now we have log all by itself on the left-hand side, and this is the log base 10, so we're going to exponentiate using the base of 10. 10 to this power, and then 10 to this power. We can evaluate this to be just 2x, and we can evaluate this to be, well, 1 with 4 zeros at the end, but you don't need to do that right now. Then our x value is going to be equal to 10 to the 4th over 2. It is perfectly okay to write 10 to the 4th over 2. You could also write 5,000. That would be appropriate as well. This is going to be a chore for me because there's going to be a lot of different equivalent correct answers. Take a look at number 14. Now, this one is very similar to the previous problem in that it is exactly the same problem. So you don't need to do this one. Moving on to number 15. You can see that there are 2 logs here that are being added. Remember, one of your log rules meant if you were adding 2 logs, you multiply. So here's what it looks like. Now for this one, we use the log rule, as I stated previously, that this plus between the 2 logs means multiply. We multiply these 2 into x squared plus x minus 2, and then we exponentiated both sides. Once we did that, we got 10 to the 1st on the right-hand side, and simply the term itself, or the expression itself on the left-hand side. We turned it into a quadratic and then factored it. And then once we factored it, we were able to split and solve. Now, before we move on to the next one, I must tell you that one of these is extraneous. X equals negative 4 is extraneous because if we were to try to use it here, the log of negative 4 plus 2 would be the log of negative 2. And you can't take a negative log. I can't say it enough. So this one, x equals negative 4, we can refer to as, that's right, extraneous. But we do have one answer, x equals 3. Moving on to the next question. Alright, this one's a bit easier if you follow the steps. You should see that the first thing we do is convert this into a division problem. Then we represent it as an exponentiation problem. Next, we eliminate the 10 and the log. We get this division problem again. And next, we're going to use cross multiplication. That's something, a blast from the past. We're multiplying both sides by x plus 1. Comes over to the right-hand side. And we distribute the 1,000. Now we're going to make this into a quadratic, one of the weirdest quadratics ever, and factor it. We can factor it in this fashion, negative 1,001 and 1, and then split and solve. But keep in mind that this answer is extraneous. Alright kids, Good luck studying.